I'm Srirekha from Excel Study Circle. I hope everyone is fine at your place. So welcome back to yet another interesting video from Excel. So in today's session, we'll have the revision and text back question discussion of the first chapter of class 9 CBSE textbook. This is a chapter from chemistry. The title is Matter in Our Surroundings. So I've already uploaded 4 videos of the same chapter, have divided the chapter into 4, and you can find the link in the description box. So I hope everyone is ready for today's session. So before starting up with the session, I request everyone to be ready with a textbook as well as a notebook. So let's recall whatever we have learned so far. Matter is made up of small particles, right? And those small particles are called as atoms. So we can say atoms are the tiny fundamental building blocks of all the matter that we see around. Everything around us is made up of atoms. They are the tiny building block, we can say, or the tiny fundamental of all matter. Okay. So what is matter? Anything which has mass, which has volume, which can be perceived by our senses can be considered to be a matter. So chair, air, book, the tablet, the mobile phone, the laptop, everything can be considered as a matter. And those emotions like the love, hatred, and the feelings, right? Anger, all this cannot be considered to be a matter. Why? Because they doesn't have any sort of mass or volume of its own. Okay, I hope that point is very much clear to everyone. Moving to the second point, matter around us exists in 3 states. Students, please understand that these are the 3 fundamental states of matter, like the solid, liquid, and gas. We are having the 4th and 5th state of matter as well. It's called BEC, which is Bose-Einstein condensate, and another state is plasma. Okay, but for the time being, we have to learn just the fundamental states of matter, which is solid, liquid, and gas. Right now, the third point, the force of attraction between the particles are maximum in solid, intermediate in between those of solid and gas, we can say it is liquid, and minimum in gas. So every matter around us, they are having some sort of force of attraction between them. The interparticle force of attraction, we would say, right? So it is maximum in case of the solid. Suppose this is a solid that I'm having. The force of attraction is maximum in this case of solid, right? When you take a liquid, suppose you're taking milk or water, any kind of liquid, the force of attraction is intermediate, or we can say it is in between the solids and the gases. And when you take any gas or hydrogen or oxygen gas, for example, the force of attraction is minimum in that kind of state. Okay, please kindly take a note of the same. Now, the fourth point, the space in between the constituent particles and kinetic energy of particles are minimum in case of solids, intermediate in liquids, and maximum in gases. Okay, this point is also very important. The space in between the particles, we call it as interparticle space. Okay, the attraction, we call it as interparticle force of attraction, intermolecular force of attraction, interparticle force of attraction, we can see. And here the interparticle space, we can say interparticle space in between the constituent particles. It is minimum in case of solid. That is, the particles in solids, they are well packed. They are very closely arranged in a systematic way so that the force of attraction is maximum and the particles are not having that, freedom of movement. The freedom of movement of particles in solids, they are restricted. They're very tightly packed, closely packed, well structured, a pattern they are having. And intermediate in case of liquids, so some space is there in between the liquid particle, we can say, and it is maximum in gases. The force of attraction is the least in case of gases, So the particles are having very much space in between them. Okay. So suppose if I'm taking this as a solid, this as a liquid, and this as a gas. Okay, solid, liquid, and gas. In solids, the particles are very well packed, closely arranged. So the space is less, force of attraction is more. In liquids, we can have, particles with intermediate force of attraction, and the space is little bit more when compared to that of solid. But in gas, the particles are having entire freedom of movement. The freedom of movement in particles of in case of gaseous state is the highest. Why the particles are having so much freedom of movement? Because the force of attraction is the least. So the space is more. I hope this point is very much clear to you. Now moving towards the next page. The arrangement of particles is most ordered in case of solids, as we've already arranged, well packed structure they are having. In the case of liquids, layers of particles can slip and slide over each other. We know that liquids are fluids, right? So the particles, they don't have that well structured manner or the pattern. We can say they slide over each other. Okay. While for gases, there is no order. The particles just move about randomly. They are free enough to move randomly. I hope this point is very much clear. So the arrangement of particles in solid, they are very neatly packed. Okay. And liquids, no, the particles are able to just slip and slide over each other. And the last one, very free random movement of particles is possible in case of gases. Right? Now, the next point, the states of matter are interconvertible, meaning they are able to change one state of matter into another. The state of matter can be changed by changing temperature or pressure. By increasing the temperature or by lowering the pressure, we can able to change the state of matter from one into another. Okay. And sublimation is a change of solid directly into gaseous state without going through the liquid state. So we have learned so many interconversion state of matter. Just to have a very quick recall, melting, meaning solid getting converted into liquid. Okay, melting is otherwise called as fusion. Okay, or liquefaction, we can say. Now, next is evaporation, which comes under the vaporization. Okay, liquid getting converted into gas. All right. Now, sublimation, where the solid substance, they are getting directly converted into gaseous state without going into that intermediate liquid state. For example, we're having few sublimable substances which are able to sublime, like camphor, the naphthalene balls, that is a mothballs, ammonium chloride, iodine, then dry ice, which is a solid form of CO2. So we're having a few examples which are sublimable. Okay. Now, gas getting directly converted to solid state, we call this as deposition. Okay. Then we have learned about the gaseous state getting converted back into liquid. It is condensation. Okay. We've already discussed all these points, but just to have a quick recall. Okay. Now, next point is all about deposition, which is a change of gaseous state directly into solid state without going through that liquid state. Now, we have learned about two phenomena, which is boiling and evaporation. Boiling is a bulk phenomenon. The particles from the bulk, that is the whole of the liquid, it changes into vapor state, right? And evaporation. So students understand that both the boiling and evaporation, they come under the same category, which is called as vaporization, where the liquid, it is getting converted into gaseous state. But what makes it different? What is the difference between boiling and evaporation is that boiling is a bulk phenomenon, whereas evaporation is a surface phenomenon, where the surface particles, they are getting enough chance to get evaporated very quickly, not the bulk particles. So it's not a bulk phenomenon. And evaporation can happen at any temperature, even below its boiling point, we can say. But boiling is that process which particularly happen at the boiling point. All right. Now, in case of evaporation, the particles from the surface gain enough energy from the medium or from the surrounding to overcome the force of attraction. There will be some sort of force of attraction between the particles, and they need to break, right? The particles need to overcome that. So in order to that, they gain some of the energy, either from the medium or from the surrounding, as we've already discussed, okay, and change into vapor state. Now, the next point, the rate of evaporation depends upon the surface area exposed to the atmosphere. Another point, temperature, humidity, and the wind speed. So these are the factors in which the rate of evaporation is being affected, we can say, right? So when the temperature is more, evaporation is more. So we can say the rate of evaporation and temperature, they are directly related. The second point, surface area and evaporation rate. It's again directly related. Whenever the surface area is more particles will have enough chance to get evaporated, and the rate of evaporation is again more. Wind speed is again directly related with the rate of evaporation. But humidity is the only factor which is inversely related with the rate of evaporation. When the humidity is high, when the amount of water vapor which is present in the atmosphere is already high, the rate of evaporation decreases. So only that factor is inversely related. All right. And we know that evaporation causes a cooling effect. Very important point. And we are having two important definitions regarding latent heat of vaporization and latent heat of fusion. Listen once again. Latent heat of vaporization. So understand vaporization is nothing where the liquid, it is getting converted into vapor state. Okay. So vaporization means liquid getting converted into gaseous state. All right. So the amount of heat energy which is required to convert a unit mass. Suppose we are having 1 liter of liquid with you. You need to convert it into gaseous state. Okay. So what amount of heat energy is required to do the same at the normal atmospheric pressure at its boiling point? Why? Because we are now discussing about latent heat of vaporization. So this happens at the boiling point, we can say. The same way we can define latent heat of fusion. Here and there you need to change the keywords, right? So fusion is sometimes called as melting. Okay, this is fusion. All right, so fusion is nothing but solid getting converted into liquid. So the amount of heat energy which is required to convert a unit mass. Suppose you're having 1 kg of solid with you. You need to convert into a liquid state. And this happens at its melting point at the normal atmospheric pressure. I hope this is very much clear. Now we are having a last table, the measurable quantities and their units to remember. So temperature, Kelvin, and the symbol is going to be K. We are having other units as well, like Fahrenheit, degrees Celsius. Okay. So understand that each and every quantity is having a SI unit. Okay, so this is the international D units, system international D unit, which is SI units. So please understand this thing. Meter in small letter M, mass is in kilogram, which is kg, weight measured in Newton, which is capital N, volume in cubic meters, that is meter cube, M cube. Density, it is nothing but mass by volume. Mass by volume. All right. So kilogram, mass is in kilogram and volume is in cubic meter. So it comes as kilogram per meter cube. You can say kg per meter cube, or you can simply say kg m raised to minus 3. So in that case, you need not put that bar, okay, like the division. And the pressure, Pascal PA. Okay, done with that. So let's quickly move towards exercise questions. The first question, convert the following temperature into Celsius scale. You can expect either of these questions, okay, like 1 or 2. Why? Because just one numerical we are having in this particular chapter, which is again important. So we need to convert 293 Kelvin into Celsius scale. Okay. So the first question, all right. So this comes as 273, 0, and yeah, 20 degrees Celsius. Sorry for the same. Here it's going to be 273, and this is 10, 10 minus 7, 10 minus 3, it is 7. Here comes it at 6, 16, 3, 1, okay, degree Celsius. I hope this is clear to you. Now convert the following temperature into Kelvin scale. So we need to just add 273, okay, in order to get it converted. Yeah. So I'll write over here 25 plus 273, which would give you 298 Kelvin. All right. So, and the third one, B question, 373 plus 273, which would give you 14 balance 1, 646, right? 646 Kelvin. Okay. So these are the answers. So please kindly take a note of the same. Yes. I hope until this it is very much clear to everyone. Let's move ahead. All right. Give reason for the following observation. Okay, so these kind of conversions you can for sure expect for your exam. Why? Because just one numerical, just unit conversion is only there in this particular chapter. That's why. And give reasoning type, yes, you can surely expect these questions. Why? Because reasoning type question is more in this particular chapter. Why? Because this is a sort of theoretical chapter only. Naphthalene balls or the mothballs disappear with the time without leaving any solid. Okay, so you have to include the keywords over here. Why naphthalene balls, which is solid, it is getting converted into gaseous state because naphthalene balls is or they are sublimable substance which undergo sublimation process. So from solid they are getting directly converted into gaseous state without that intermediate liquid state. Okay, so you need to include that keyword sublimation over here and explain it directly changes from solid to gas. All right. And the B question, we can get the smell of perfume sitting several meters away for sure. So what is the process which is undergoing here is diffusion. Diffusion is nothing but the process where the intermixing of two different states of matter happen on their own, right? So here the smell of the perfume, it is getting spreaded all over. Even we are far away, we get that smell. Why? Because the perfume particle, they contain that volatile solvent in it, which easily vaporizes, and the particles diffuse in between the space of the air particles. They travel, and we can get that smell. Okay. So with the help of diffusion process, you need to explain the same. Now, going back to the fourth question, arrange the following substances in increasing order of the force of attraction between the particles. Okay, so understand that the force of attraction, it is maximum in case of solid, intermediate in case of liquids, and it is less. The force of attraction is very less in case of gas. Okay, so they have given three options over here, which is water, sugar, and oxygen. So water, you need to know it is liquid in state, and sugar, it is solid in state, and the gas. Yes. Okay, fine. Oxygen is a gas, right? So increasing order of force of attraction, so sugar comes the last. So we can say oxygen, which is less than water, which is sugar, okay, and less than sugar. Okay, so sugar, it is having the highest force of attraction, we can say, then water, then oxygen. Okay, so understand that order: gas, then liquids, then solids. This is in case of force of attraction. This will be just the reverse in case of the interparticular space. Okay. Now, what is the physical state of water at 25 degrees Celsius? At 25 degrees Celsius, yes, it's just going to be in liquid state. At 0 degrees Celsius, what happens is that It's a melting point of ice. So certain ice or the particles, they've already been started to melt, but not all the particles. So we can say both solid and liquid state will be there. Meaning some of the particles, they've already been started to melt, and we can say that liquid is also present, and the other particles, it remains solid, right? It would take some time for the ice cube to completely melt, right? Similar way, 100 degrees Celsius is the boiling point of water, where the water has started to boil. So we can say certain particles have been converted into gaseous state, but still there will be some liquid state remaining. So both of the gaseous as well as liquid state will be present. Now the next question, give two reasons to justify water at room temperature is a liquid. So we are having ample enough of reason to justify that water at the normal room temperature is liquid. So in important 2 points, we can say at the normal room temperature, the melting point of, or the boiling point of water is going to be 100 degrees Celsius, right? And water, it solidifies or it freezes, or we can say the freezing point of water is going to be 0 degrees Celsius. So these can be considered to be two reasons to simply justify that water at the normal temperature is liquid. In other words, water is said to be liquid. Why? Because it is having all the characteristic properties of any liquid. Like it is a fluid, it is having the tendency to flow, right? And the particles, they're having enough space in between them. That is why, they are easily transformed from one container into another. The force of attraction is intermediate, the particle space is intermediate, and water, it is having a definite volume but not any shape or any size. It would take the shape of the container in which it is being taken, right? So there are so many factors which helps us to justify that water at room temperature is liquid. So depending on the marks, you can add more points or you can just cut off the points as well. Now B question, an iron almirah is a solid at room temperature. So definitely iron almirah, it is said to be solid. Why? Because its melting point of the iron is higher than that of the room temperature. We can say solid almirah, it is having definite shape, definite size. It is very rigid. We cannot easily transform its shape by applying any kind of force. It's not very much easy at the normal room temperature, right? You can say about the force of attraction, it is very high. The particles are having well packed structure, particle space is least, likewise. And it's not a fluid, it's very rigid as well. Okay, now why is ice at 273 Kelvin more effective in cooling than water at the same temperature? So either you can expect question number 7 or 8. Okay, very important. Ice at 273 Kelvin is more effective in cooling. Why? Because it is having latent heat of fusion. Latent heat of fusion. So students, I request everyone to try practicing to answer the questions with the help of the keywords. All these keywords are very much necessary in your answer so that you'll get full on full marks. Rather than going for the just the verbal explanation, you need to include more of the keywords and precisely give the answer. All right. Now, ice is having more of that hidden heat in the form of latent heat of fusion, which is not present in the water. So we can say that ice at 273 Kelvin is more effective in cooling than when we compare to that of the water at the same temperature. Similar way, 8th question, what produces more severe burn, boiling water or steam? The answer is steam. Steam causes more severe burn than boiling water. You need to include that statement. And why? Because steam is having a form of hidden heat. That is called as latent heat of vaporization. Okay. And that hidden heat or this extra heat is not present in the boiling water. So once the water starts boiling, Still again, if you are applying the temperature, boiling water would acquire that extra amount of heat and it will be stored in the form of hidden heat, which we call it as latent heat or vaporization, and which is again used to convert the boiling water into steam, that is from liquid to gaseous state. So steam has got that extra energy, right, which is stored in the form of hidden heat, we can say. And that latent heat of vaporization, that extra energy is not there for the normal boiling water, we can say, right? So what happens is that when steam falls on one person's skin or body, this extra energy is given out to that person's body and condensation occurs, where the gas converts back into the liquid, and during that condensation, when the gas or the steam it is getting converted back to the liquid state, this extra energy is given out to his body or to the person's body. That is why that person feel severe burn with steam. Okay, so we can expect this question for 2 or 3 marks. And the ninth question, yeah, we are done with the exercise question. This is the last one. A, they have given it as solid. By increasing heat and decreasing pressure, it is getting converted. Okay, so A, it is getting converted into liquid. We call it as melting or fusion. We can liquefy it. So there are several terms. Okay, now solid, which is directly getting converted into gas, this is E. Sublimation. And liquid getting converted to gas, that is B. You can simply write vaporization. So in vaporization, it can happen with the help of boiling as well as evaporation. At the boiling point, boiling happens. At any point below the boiling point at normal temperature, evaporation can happen. So either you can write evaporation or just a vaporization. Okay, no issues, both are correct. Gas to liquid, C for condensation. All right. And D, it is liquid getting converted to solid, is solidification, right? Liquid, it is getting solidified. And F, gas directly getting converted to solid, it is deposition. Okay, so with that we are done with this chapter. I hope whatever we have discussed so far is very much clear to you. So very simple chapter in 9th grade chemistry, complete of theoretical, and you need to practice more of the reasoning type questions. Okay, so I hope this video will surely help you for gaining more knowledge, for attending your examination and much more confidence. And thank you so much for watching. We'll soon come back with the second chapter of chemistry. So please kindly follow. Okay, so thank you so much.